Now we'll discuss cases of a sliding on rough surfaces. The very first thing about sliding of a body, we know that on a rough surface, a body at rest will slide only if by some external force friction approaches to the value mu n, which we call limiting friction. We know very well that when external force is applied, static friction appears, and if force is increased, friction also increase. Like say in case of a horizontal ground, if a body, a block of mass m is placed, and if it is pulled with a horizontal force F, static friction appears over here, and we can say on increasing this force, friction will also increase, and this friction always tries to balance the external force. When this becomes equals to mu n, then we can say body will start sliding. So we can say body will start sliding only when the value of friction approaches the value mu n. Similarly, we can take up another example in case of a horizontal plane. Say we are having a plank of mass capital M over which a small m block is placed. If we pull this block with a force F, if ground is smooth and the upper surface is rough having a friction coefficient mu, you can say when this is pulled on this lower block, friction act in backward direction, on the upper block friction act in forward direction. And initially the value of friction will be very small and both will move together. So we can simply state here common acceleration of blocks can be written as F by m plus small m. If we write down the equation of motion for a small m, only friction is acting on it due to which it is moving forward. So for a small m we can write friction is equals to small m into A, that is F by m plus small m. Here again you can say if we increase the value of capital F, acceleration increases and friction also increases. But here we can say small m will slide over capital M when this friction approaches the value of mu n, and in this situation the normal reaction acting on it must be equal to weight of the block because no other vertical force is present. So here it will slide when friction, which is mf upon capital M plus small m, it will be equals to mu mg. Here m gets cancelled out and you can find out the value of force at which the upper body will start sliding on the lower body is equals to mu into capital M plus small m into g. So this is the force at which the upper body will start sliding. In general, whichever cases we are going to deal now, we are going to discuss only one concept, that is as soon as the value of friction approaches the value of mu n, that is limiting friction, the body will start sliding on the surface on which it is at rest earlier. So let's see some examples based on this also. In this example, we are given with a system of blocks, pulley and a string, and we are required to find the mass m such that on releasing the system, block A will start sliding on B. Here you can see the bottom surface is smooth and the friction coefficient between block A and B is 0.2. Here we can say when we release the system, mg will act on it in downward direction because of which a tension will be there. The similar tension will pull the 20 kg block. So this 20 kg will experience a friction in backward direction and no friction will act on bottom as it is smooth. Opposite friction F, same value, will act on block A, due to which it will start sliding in forward direction. And we can say for low values of M, both the blocks will move together. So here we can say for low values of capital M, A and B will move together. And we can write down the equations directly, like for this block, if it is coming down with A, these two will also move forward with the acceleration A. For this M, we can write the equation mg minus t is equals to ma. And for both of these blocks, if this is considered to be a 25 kg block and only tension is the accelerating force, we can write t is equals to 25a. From these equations, if you add the two, you can see it will be mg is equals to 25 plus m into a. On adding these two equations, we'll get the acceleration, that is m by 25 plus m into g. Now if we just draw the free body diagram of block A, here you can see if this block A, the only force acting on it is friction, due to which it is also accelerating with A. So for block A, equation of motion can be written as friction is equals to, its mass is 5 multiplied by acceleration will be mg upon m plus 25. And we can simply state, as the value of capital M increases, friction will also increase. And this block A will start sliding on block B as soon as the value of friction approaches the limiting value. Here we can easily calculate the limiting value of this friction, that will be mu multiplied by the normal reaction acting on it. As in vertical direction, the blocks are not in motion, we can say its normal reaction is 5g. So it can be written as 0.2 into 5 into g can be taken as 10. So this will be 10 Newton. So we can say as limiting value of friction between block A and B is 10 Newton. Block A will start sliding as soon as this friction approaches the value 10. And now you can easily solve it. It will give you g can also be taken as 10. So this g and 10 gets cancelled out. It will give us 5m is equals to m plus 25. So m can be written as 25 by 4, that is 6.25 kilogram. And this is the answer to our question, that if this mass is of value 6.25 or more kilograms, then block A will start sliding on block B.